You know I came through with the fuego. You know I came through. Hey, you know I came through. You know I came through with the fuego. You know I came through. Hey, you know I came through. Nowadays, I cannot lay low. I cannot lay low.
So, welcome to our pre-calculus class and hello STEM students. So, for today's video lesson, we will learn about equations of parabola. So, specifically the standard form or the vertex form of the equation of parabola. So, we have two learning competencies for today. The first one is define a parabola and graph a parabola given an equation in vertex form. So let's recall the definition of parabola. So it is a type of conic section which is formed when the intersecting plane is parallel to an element of the surface, or when our double nape cone is cut by a plane, so diagonally. Okay, and there our parabola is formed. Okay, so another definition, a parabola is the locus of a point that moves such that its distances from a fixed point and fixed line are equal. So this is the illustration. Suppose we have this line from this point to a line, and then from this point to this point. Okay? So notice that the distances from this point to the line and from this point to this point is equal. Let's derive the standard equation of the parabola. So suppose we have this distances PF and P sub L. So we have this point F, coordinates are 0 and C. So this will be the fixed point in our parabola, or we call this the focus. And then we have here the fixed line in the parabola, or this line L, or the line y equals negative c. So this is the fixed line in the parabola. We call this the directrix. Okay? And we have this point P, be any point on the parabola. So the coordinates are x, y. So to derive the equation, we have here two distances. So we will be equating this. So the first distance is from the point on the parabola to our focus, or the fixed point. And then the second distance is from the point on the parabola to the fixed line, to the directrix. Okay, so solving the distances, we will be applying the distance formula. So the distance formula is square root of x sub 2 minus x sub 1, so quantity squared, plus y sub 2 minus y sub 1, quantity squared. So let's substitute the given points. So letting our point xy be the x sub 2 and y sub 2, and point f is the x sub 1 and y sub 1. So solving for the distance, we have x sub 2 minus x sub 1. So x minus 0, quantity squared, so that's x squared. And then plus y sub 2 minus y sub 1. So y minus c, quantity squared. Okay, and then don't forget the square root. So equals, here class we have a vertical line here. So yung x natin, the x is still the same, no? So wala tayong run dito. So dito tayo sa y lang. So y sub 2 minus y sub 1, then absolute value, we can get the distance. So that's y minus, the y value here is negative c. So y minus negative c. So simplifying, that is y plus c. Okay? So to eliminate the radical sign on this side, let us square both sides of this equation. Okay? So when we square both sides, the radical sign on this side will be eliminated, and the y plus c here on this side will be squared. Okay? And then here, just square this. So squaring this, y minus c, so that's y squared. Then y times negative c, so negative cy times 2, that's negative 2cy. And then square of c, that is c squared. So on this side, square of y plus c. So y squared plus y times c, so that's cy times 2, that's 2cy. Plus square this, so c squared. So simplifying, so we have x squared, and then y squared is cancelled. Ayan. And then transposing this to the other side, so it will become 2cy plus 2cy, so that's 4cy. And then the c squared will be cancelled out. So this is the standard equation of our parabola. To summarize, class, we have four equations of parabola having vertex at 0, 0. So the first one is the parabola that opens upward. So the equation is x squared equals 4ay. And then, next is the parabola that opens downward. So the equation is x squared equals negative 4ay. Okay? So notice that when the parabola opens upward or downward, the x is squared. Okay? And the y is not squared. Okay? So when the parabola opens upward, the coefficient here in y is positive. And when the parabola opens downward, the coefficient here in y is negative. So we have to take note of that. And then we have the parabola that opens to the right and to the left. So when the parabola opens to the right or to the left, the y is squared. So for this one, y squared equals 4ax. And for the parabola that opens to the left, we have y squared equals negative 4ax. Okay? So notice the difference between the two equations. So upward or downward, x is squared. And then opening to the right or to the left, y is squared. Okay? So we have to memorize those four parabola, four equations for the parabola. Example, determine the focus and directrix of the parabola with the given equation. Sketch the graph and indicate the focus, directrix, vertex, and axis of symmetry. So for number 1, we have x squared equals 12y. So the first thing to do, class, is identify our 4a. So take note that the numerical coefficient of y, that is our 4a. Okay, and we will use that to solve for the value of a. So 4a is equal to 12. So divide both sides by 4. So a is equal to 12 over 4. So that's 3. So our 2a is 2 times 3, so that's 6. And our 4a is 3 times 4, so that's 12. So this will be our distance from fo from focus to vertex, or from vertex to focus. and the distance from vertex to our line directrix. So let's graph it. So since the vertex is at 0, 0, let's locate it. And then, since our parabola has positive coefficient on y, so the parabola will open upward. Okay? So from the vertex, we will move a units to the focus. So the focus from the vertex to the focus is a units. So that's 3 units. So 1, 2, 3. So this is our focus. So the point 0, 3. So note that that is a units. And then from the vertex to our fixed line. So our fixed line or the directrix. So we will also move 3 units. So 1, 2, 3. So we will draw our directrix. So the directrix is our fixed line. So the equation of the directrix is y equals negative 3. Okay? Okay, so next is locate the endpoint of the latus rectum. So this one is the distance from F to L or R, the endpoints of our latus rectum, and that is equal to 6 units. So 1, 2, 3, 4, 5, 6. So this point L, so the coordinates are negative 6, 3, so 1, and then also we will move 6 units to the right. So 1, 2, 3, 4, 5, 6. So this is R, that is 6, 3. Okay, now we can trace our parabola. So this should be is a smooth curve. Okay, so that is our parabola. So let's again, this is 2a units. This is also 2a units. From vertex to directrix, that is a units. From vertex to focus, that is a units. So those are the distances that we have to remember. So let's identify our focus. So focus is, that's right, focus is at here, that is 0, 3, So vertex is at 0, 0. Then equation of directrix is y equals -3. And then the axis of symmetry is this vertical line. So notice class that the parabola is symmetric with respect to the axis of symmetry. Or when we pull the parabola through this line, the parabola will coincide. Half of the parabola will coincide. So the axis of symmetry is the line x equals 0. So this vertical line. Okay. Our second example, so we will graph x squared equals -6y. So as we can see, x is squared, so our parabola would open upward or downward. So since the numerical coefficient of y is negative, so our parabola will open downward, or it will look like something like this. Now let's solve for our value of a. So this is our 4a. So 4a equals 6. Divide both sides by 4. So a is 3 over 2. And our 2a is 3 over 2 times 2. So that's 3. And 4a is 6. So now let's plot our point. So our vertex is at 0, 0. Okay. So let's name our point. And then, since the parabola would open downward, so we will locate A units downward. So we will locate, from our vertex, we will locate 3 over 2 units, or 3 half units, or that's equal to 1.5. So our focus is 0, -3 over 2. Okay, and for our directrix, we will move 2 units upward. 3 over 2 units upward, rather. So that's 1.5. So let's draw our imaginary line. So remember, class, a directrix is just an imaginary line. It does not included in the points that belong to our parabola. So now, next is locate the endpoints of the lattice rectum. So we will move 2A from the focus. So left or right. So from our focus, we will move 3 units. So that's 1, 2, and 3. So that's negative 3 here. And then we will also move 3 units to the right. So 1, 2, 3. Okay, so here, let's name the coordinates. So negative 3 over 2. And here, so we name L and R for the endpoints of our lattice rectum. Okay. But you can use any letter. So I'm just using L and R just to so that it will be near to the letter starting with our lattice rectum. So the coordinates here is 3, negative 3 over 2. Okay, so now we can trace our parabola. Okay, it might not be perfect. Okay, so let's identify the focus. Focus is at 0, negative 3 over 2. The equation of the directrix is y equals 3 over 2, this line, and the axis of symmetry is this line, class, and that line is x equals 0. Okay, for our third example, so we will graph the equation y squared equals 8x. So since y squared, so our parabola will open left or right. But since this is positive, the parabola will open to the right or rightward. So roughly it will looks like this. Okay, for the next step, we will solve for the value of a. So the coefficient of x is the 4a. 4a equals 8. Divide both sides by 4. So a is 2. And 2a is 4. And our 4a is 8. Okay. So now, let's graph it. So the vertex is still at the origin. So let's locate our focus first. So focus would be a units or 2 units from the vertex. So since the parabola will open to the right, so we will move 2 units to the right. 1, 2. So this is our focus. Coordinates are 2, 0. And then let us graph the directrix. So from vertex, we will move 2 units to the left. Okay. So this will be our directrix. And the equation is x equals negative 2. Okay, and then let's draw the endpoints of the lattice rectum. So from focus, we will move 2a units or 4 units. So we will move up and down. 1, 2, 3, 4. So that's 4. And here is 1, 2, 3, 4. It's negative 4 here. So this point and this point. So let's name it R, and the coordinates are 2, 4, and for this one, for other endpoint, 2, negative 4. Okay, so now we can trace our parabola. Okay, so that is our parabola. And our vertex is 0, 0, and directrix, the equation of the directrix is x equals negative 2, and our focus is at 2, 0, okay, and the axis of symmetry is this line plus this line, so that's y equals 0. Okay. Parabola whose vertex at hk. So these are the standard equations of the parabola when vertex is at hk. So first one, when the parabola opens upward, so square x is squared, so hk. So this is the equation. X minus h quantity squared equals 4c times y minus k. And then when the parabola opens downward, the equation is this one. So the coefficient of y just becomes negative. So x minus h quantity squared equals negative 4c times y minus k. And then when the parabola opens to the right, so this one, y minus k quantity squared equals 4c times x minus h. So the coefficient of x is positive. And then the parabola that opens to the left, so y minus k squared quantity squared equals negative 4c times x minus h. So the coefficient of x is negative. So the axis of symmetry is x minus h. So in vertical, and axis of symmetry is y equals k when it is horizontal. So for our fourth example, we will graph the equation x minus 1 quantity squared equals 12 times y plus 1. So the opening of our parabola is upward since this part is squared. And then let's solve for a. So this is our coefficient. So for a equals 12. Divide both sides by 4. So a is 3 and 2a is 6. Okay. And our vertex is at, so this is h and k. That's in 1. Since this is positive, so it means it is multiplied by negative numbers. So rk is negative 1. So first is locate our vertex. So that is at 1, negative 1. So the vertex is at 1, negative 1. And then next is locate our focus. So since the parabola will open upward, we will move from the vertex, we will move 2 units. We will move 3 units, so a units from the vertex. So that's 1, 2. 3. Okay, and that is 2. So here is our focus. The coordinates of the focus is 1, 2. And then let's draw our directrix. So the directrix is 3 units downward since our parabola opens upward. And the equation is y equals, this is 1, 2, 3, 4, negative 4. Okay, and then locate the endpoints of the lattice rectum. So from our focus, we will move left and right 2a units. So 6, 1, 2, 3, 4, 5, 6. And that's 1, 2, 3, 4, 5. And then here, so from this focus, 1, 2, 3, 4, 5, 6. And that is 1, 2, and this is 7. So the endpoints of the lattice rectum is negative 5, 2, and this one is 7, 2. Okay, so now we can trace the curve. Okay, so our focus is 1, 2. Vertex is 1, negative 1. Equation of directrix is y equals negative 4. Axis of symmetry is this line, class. So what is the equation of that? That is x equals 1. Okay. So for our fifth example, so we will graph this equation. So since y is squared, it means the parabola will open to the right or to the left. And since the coefficient of x is positive, so it means that our parabola will open to the right. Then for the value of a, this one is the 4a. So that's 4. Divide both sides by 4 and a is equal to 1. 2a is equal to 1 times 2. So 2a is equal to 2. So first step is to locate our vertex. Vertex is at each k. So this is h and this is k. So vertex is at 3, 2. 1, 2, 3, 2. Okay, so since our parabola will open to the right, so we will move a units. We will move a units to the right for our focus. So this point, F will be 3. Oops, that's 4, 2 for our focus. Okay, and then let's draw our directrix. So we will move 1 unit to the left of our vertex. Okay, so the equation is x equals 2. Okay. And then let's locate the endpoints of the lattice rectum. So from the focus, we will move 1 unit upward and 1 unit downward. So this is for that is for 1. Okay, and this one is for 3. Okay, so we can now trace our curve. Okay, so that's our graph. Our vertex is at 3, 2, focus is at 4, 2. Okay, and equation of directrix is x equals to axis of symmetry is 1. So that's y equals to this line class, the horizontal line. Okay, for our practice exercise, let's try to solve this problem. Write the equation of the parabola with vertex B at 0, 0, which satisfies the following conditions. So for letter A, axis on the y-axis and passes through 6, negative 3. So get a sheet of paper and try to answer it. You can pause the video and then later I will give you the answer. Okay, so let's solve the problem. Since the given axis of the parabola is the y-axis, so our parabola could either open upward or opens downward. Okay, so the equation that we should use is x squared equals 4ay since the vertex is at 0, 0. Okay, so since the parabola will pass through this point 6, negative 3, to find the value of a or 4a, we will use this. So this is x, y. We will substitute to the equation. So that 6 squared equals 4a, y is negative 3. So to finally solve for a, we just have to divide both sides by negative 3. Okay, so cancel this. So we will have 4a equals 6 squared. That's 36 over negative 3. And that is equal to negative 12. So this is our 4a. So to write the equation, so x squared equals 4ay. So 4a is negative 12. We will just substitute it. Okay, so this is the equation of our parabola. Okay, next, for letter B, write the equation of the parabola with vertex is still at 0, 0, that satisfy the following condition. So for letter B, focus is at 0, 0, 4 over 3, and the equation of the directrix is y plus 4 over 3. So this one, we can write it as y equals negative 4 over 3, this equation. So let's try to visualize our parabola. So f is at 4 over 3. 0, 4 over 3. So, okay, so 0, 4 over 3. Or 1 point something. That is our focus. So, if that is the focus and this is the vertex of the parabola, and the directrix is at 4, negative 3, here, so that's the line y equals negative 4 over 3. Therefore, the value of A is 4 over 3. And 4A is 4 over 3 times 4, and that is equal to 16 over 3. So that is our 4A. So since the parabola opens upward, because this is the focus and this is the directrix, so the equation that we will be using is x squared equals 4ay. So substituting our 4a, that's x squared equals 16 over 3y. So this is the equation of the parabola. For our fourth exercise, write the equation of the parabola with vertex v at 0, 0, which satisfies the given condition, focus at 0, 2. So try solving it, and then later I will reveal the answer. Okay, so let's answer it. The focus is at 0, 2. So let's visualize our parabola. F is at 0, 2. And the vertex is still at 0, 0. Okay, so if the focus is there, our parabola will open upward. So the value of A is 2. So now, since the parabola opens upward, we will use the formula x equals 4ax. So x squared. So 4a is 4 times 2. So that's 8. So 8x. This is the equation of our parabola. For our fourth exercise, write the equation of the parabola with vertex v at 0, 0, which satisfies the given condition, focus at 0, 2. So try solving it, and then later I will reveal the answer. Okay, so let's answer it. The focus is at 0, 2. So let's visualize our parabola. F is at 0, 2. And the vertex is still at 0, 0. Okay, so if the focus is there, our parabola will open upward. So the value of A is 2. So now, since the parabola opens upward, we will use the formula x equals 4ax. So x squared. So 4a is 4 times 2. So that's 8. So 8x. This is the equation of our parabola. For our fifth exercise, so write the equation of the parabola with vertex B at 0, 0, which satisfies the following conditions. So for letter E, the lattice rectum is 6 units and the parabola opens to the left. So since the length of the lattice rectum of the parabola is 6 units, so it means that 4a is 6. And the parabola opens to the left. The vertex is still at 0, 0. So we can use the formula y squared equals 4ax. So opens to the left. So the coefficient here is negative. So now we can write the equation of the parabola. So negative 6x. Just substitute the value of 4a, which is 6. Okay, so this is the answer. For our problem solving, so let's solve the following problem. A satellite dish has a shape of a paraboloid where each cross-section is a parabola. Since radio signal parallel to the x-axis will bounce off the surface of the dish to the focus, the receiver should be placed at the focus. How far should the receiver be from the vertex if the dish is 12 feet across and 4.5 deep at the vertex? Okay, so this is the illustration. So this is our satellite. So the height is 4.5. So it is 4.5 deep and it is 12 feet across. Okay. And then if we graph the parabola into the Cartesian plane, it will look like this. So using the origin as the vertex of the parabola. So at this point, that is 6. So to the left, that is 6. So that's 12 feet across. And the height is 4.5. Okay, so the question is, how far should the receiver be from the vertex? Okay, so we are asking to find the focus of the parabola. So, since the parabola opens upward, the equation that we will be using is x squared 4ay. Okay, and then, so using this point 6, 4.5, so as a point in the parabola, so we can now solve for the value of a. So x squared, that's 6 squared, substituting 4a, y is 4.5. So to solve for a, we will just divide both sides by 4 times 4.5. Okay, so cancel this out. So a equals 36, 6 squared, over 4 times 4.5. So the value of a is 2. Therefore, the receiver should be placed 2 units away from the vertex. Okay. Let's try this. You can pause the video and try to answer it in a sheet of paper. Okay, so let's answer it. The cable of a suspension bridge hangs in the shape of a parabola. The towers supporting the cable are 400 feet apart and 100 feet high. If the cable is at its lowest, and that is 30 feet above the bridge at its midpoint, how high is the cable 50 feet away horizontally from either the tower? Okay, so let's take a look at this figure. So the two towers are 400 feet apart. So the vertex of the parabola is at 0, 30 at its lowest point. And then, so to the left, that's 200, and to the right, that is 200. So they are 400 feet apart and 150 feet high. Okay. And then the lowest point or the vertex is at 0, 30. Okay. The question is, how high is the cable 50 feet away from either the tower? So from 200, so that is 150 apart from the tower. Okay. So it just means that we are solving for y of this point, for the y value at that point. So since the parabola opens upward, so let's write first the equation of the parabola. So x minus h squared equals 4a y minus k. So we will use this formula since the parabola opens upward. And then substituting the vertex, and that's x minus 0 squared equals 4a y k is 30, so minus 30. Okay, so simplifying, we have x squared equals 4a y minus 30. Okay, so since we have a given point that satisfies the parabola, which is 200 and 150, so we can use that information to solve for the value of a. So substituting this point, so x is 200 squared and 4a. So y is 150 minus 30. So let's solve for 4a. So 200 squared, that is 40,000. So 4a, 150 minus 30, that's 120. Okay, so to solve for 4a, we will just divide the equation by 120. Okay, so 4a is simplifying. Okay, so 4a is 1,000 over 3. Okay, so now we can write the equation of the parabola. And that is x squared equals, substituting in this equation, substituting the value of 4a, which is 1,000 over 3 y minus 30. Okay, so now we can find the value of y here. since we have the equation of the parabola. So by substituting just the value of x, so 150 squared equals 1000 over 3 times y minus 30. So simplifying, let's square this. And that is equal to 22,500 . Okay, and then multiply the equation by 3 to eliminate 3. So 22,500 times 3. So let's just copy this one. So 22,500 times 3. And that is 67,500 over 1,000 times y minus 30. Now, divide both sides of the equation by 1,000. Okay, so the answer is 67.5 y minus 30. So cancel this out. And then then 67.5 transpose negative 30. So that will become positive 30. So y is 97.5. So the unit is in feet. Okay. So this is the value if x is 150. Okay. So that's all for today, class. So if you have learned something from this video, just click the subscribe button and hit the notification bell for our future videos.